Hey everybody, we're going to go through a quick run through of taking the inverse of a 2 by 2 matrix. So we're going to consider a generic 2 by 2 matrix with indices A, B, C, and D, and its inverse will be is shown with the following relationship. So to take the inverse of matrix A, you're going to multiply it by 1 over AD minus BC. This number is known as the determinant. And you're going to multiply that by a version of matrix A which have had some of its numbers switched around. So the top left and the bottom right have switched spots, and the top right and the bottom left have switched signs. So you'll notice that A and D have switched spots to be in opposite corners, and you'll notice that B and C have switched signs to be the opposite of what the number originally was. You also notice that if A times D minus B times C, if that equals 0, then there is no inverse to this matrix, because the determinant will be undefined, which means that the inverse of matrix A will also be undefined. So let's go through a quick example. Alright, so given matrix B here, we're going to take the inverse of matrix B. We are going to multiply it by the determinant, which is 1 over, we're going to multiply each number after we rearrange it by the determinant, which is the top left times the bottom right, which is 6 times 5, subtract 7 times 1, which is 7, and then we're going to switch the numbers around to help us find the inverse. So we are going to switch the positions of 6 and 5. So 5 will end up in the top left and 6 will be in the bottom right. And now we will switch the signs of the other diagonal. So it's the opposite of the top right corner and the opposite of the bottom left corner, rather. So we can evaluate this determinant here, which is 30 minus 7, which is 23, hopefully. And now you can multiply each number in your matrix by the determinant. So the inverse, hang on a second. So the inverse of matrix B will be 5 over 23, negative 7 over 23, negative 1 over 23, and 6 over 23. So that is how you get from an original 2 by 2 matrix and to find its inverse. Another thing that is important to remember here is that if you multiply the original matrix by its inverse, it will result, the product will be the identity matrix, which is a square matrix with ones along the diagonal. So we're going to have a quick look at that as well. Alright, so we're going to have a look at this product, which we covered last time. So we are going to take the first row in our first matrix. So we have 6 and 7. And we're going to start off by multiplying it by the first column in our second matrix. So we're going to take the first times the first and add the second times second. So the first number in the first one and the first one and the second one, and multiply those two together. So, okay, didn't get a calculator. Obviously, we won't have a calculator on the test on Monday, but for time's sake, this will be 30 over 23, oops, plus, or actually, plus negative 7 over 23 as our first one. Then we are going to take our first row and multiply it by the second column in our second matrix. Sorry, 6 times negative 7 will give us negative 42, I believe. And we're going to add on 7 times 6 over 23, which is also a 42 over 23. And we're going to start seeing a pattern here, hopefully. So to finish our product, we're going to move on to the second row of the first matrix, and we're going to start off by multiplying by this column to get this number, and then multiply this row by this column to finish to get that number. And so this is 5 over 23 plus 5 times negative 1 is negative 5 over 23. And then with the second column, we have negative 7 over 23 plus 5 times 6 is 30 over 23. So when we evaluate our fractions, we have 30 minus 7, which is 23, all over 23. We have 42. We have negative 42 plus 42, which is 0. We have 5 minus 5, which is also 0. And 23 over 23 again. This is the identity matrix, which is 1s across the diagonal and 0s in the rest of the spots. So, to bring it all back together, if we have a 2 by 2 matrix and we are able to take its to discover its inverse should the determinant be defined, and you just have to find some kind of trick to remember which ones to switch. So what I do is like switch the spots for these ones and switch the signs for these ones, and like wave my pencil in the air. And then that is usually pretty easy. It's like finding it's a similar process to finding a unit vector, with more numbers in the box. And then this relationship also comes in handy as well. So hope that helps, and have a great day.